Alright, a vehicle manufacturer tests their vehicle to determine the maximum deceleration of different models. For one particular model, the average stopping distance was 12.9 meters when its initial speed was 60 kilometers per hour. Calculate the average deceleration of this model. Alright, cool. So my A is what I'm trying to find. Stopping distance is 12.9 meters. My V initial is 60 kilometers per hour. And obviously I'm going to change that, so I divide that by 3.6. So 60 divided by 3.6 is 16 meters per second. What else? I know my V because that technically should be 0. Alright, let's go. So my T is missing, so I can use this equation. Right, my V squared would be 0, my V naught squared would be 16.7, 2, and then negative, A is what I'm trying to find, and 12.9. So my A, I'll just have to rearrange it, will be 16.7 squared divided by 2, 12.9. Now this needs a negative because I need to rearrange that. So when I put that in the calculator, I get negative 10.8 meters per second squared. And that's it. Now B, calculate the average time it will take to this model to stop. Right, here's what I'm trying to find. Again, I'm going to try and use those values. My V is going to be 0, my V naught is, I calculated to be 16.7 meters per second. So technically I've got all the information. A I found as well. So it doesn't really matter which equation I use as long as it has a T. So that's what I'm trying to find. What am I missing? S is 12.9. Okay, so the easiest is probably going to be V equals V naught plus AT, as that just has one T, whereas the S equals half. Let me write down. S equals V naught T plus half AT squared. This one has two values of T, so it's just a little bit confusing, like it's a little bit annoying to find, so I'm not going to use that one. So let's use V equals V naught plus AT. So my 0 equals V naught 16.7. Take 10.8 because that's the acceleration time. So my time, if I rearrange that, I should get 16.7 with a 10.8. So that would be 1.55 seconds.